This week we'll be covering Chapter 6, Surveys and Observations, describing what people do. We'll talk about these two methods of measurement and how researchers use them to describe people and their behaviors. We'll specifically be talking about how both surveys and observations are used to measure one variable at a time for frequency-level claims. Remember, frequency-level claims are simply when a single variable is described in terms of how often it occurs. So while this chapter is about frequency claims, it also focuses on construct validity. When we look at data for frequency claims, it will have been collected from either surveys and polls or from behavioral observations. Researchers can also make other types of claims from these data, such as association or causal claims. However, the focus of this chapter will be on how researchers use surveys and observations to measure one variable at a time for frequency claims. We'll cover construct validity for both surveys and polls, as well as behavioral observations. So let's talk about surveys and polls. For our purposes, these two terms mean the same thing. They are a method of asking people questions, either face-to-face, over the phone, on written questionnaires, or simply online. Let's also remember that construct validity is an assessment of how well our method of questioning truly gets at the idea, or construct, we are intending to measure. It's how well we are operationalizing our construct. We're going to go over these three main subsections in our discussion of the construct validity of surveys and polls: choosing question formats, writing well-worded questions, and encouraging accurate responses. Survey questions come in a variety of different formats. Choosing the correct one to use depending on the construct or idea you are trying to measure is important. Open-ended questions are where respondents may answer any way they like. A pro to this method is that they provide researchers with a lot of rich information. However, a con is that processing the coding and categorizing the diverse responses can be difficult and time-consuming. Therefore, researchers sometimes restrict the answers that people provide in one of the following ways. The first is the forced choice format. Here, people provide their opinion by choosing the best of two or more options. They are used in political polls fairly often. For example, which of the following candidates would you vote for president? For asking for opinions on current issues, for example, do you think women should have the right to choose whether they have an abortion, yes or no? Or to determine a preference between two choices, for example, which of these two statements describes you? I like to be the center of attention. It makes me uncomfortable to be the center of attention. While this limits the answers people can provide, it narrows and focuses the question, while also making interpreting and analyzing the results much simpler. The second method is using what are known as Likert scales. Here, people are presented with a statement and asked to use a rating scale to reflect their degree of agreement. A Likert scale is anchored by the terms strongly agree, neither agree nor disagree, and strongly disagree. Some scales deviate from this format slightly, while maintaining the same nature of a Likert scale. For example, they may use 7 anchors rather than 5. These scales are referred to as Likert type scales, since they deviate slightly from the original format. Finally, there is the semantic differential format. Here, respondents are asked to rate a target object using a numeric scale anchored by adjectives. For example, rate your professor on level of difficulty on a scale from 1, show up and pass, to 5, hardest thing I've ever done. So while each of these survey methods can be useful in certain circumstances, it's important to consider the nature of your question and determine which method will yield the best results with the highest construct validity. In order to interrogate the construct validity of a survey, we need to look at how well a variable was measured. To do this, we need to determine that the questions are clear and straightforward to answer. Leading questions may bias a certain response over another. Sometimes two questions seem to be asking the same thing, but they yield very different responses depending on how they are worded. For example, of the two questions, how fast do you think the car was going when he hit the other car, and how fast do you think the car was going when he smashed into the other car? Which question do you think would lead people to give a higher speed estimate? Likely the second question, since it uses the word smashed rather than hit, which gives off the impression of a stronger impact. If the goal of a survey is to capture respondents' true opinions, then questions should be worded as neutrally as possible. Double-barreled questions are when two questions are asked in one. For example, do you agree that the Second Amendment to the United States Constitution guarantees your individual right to own a gun, and that the Second Amendment is just as important as your other constitutional rights? Here, both questions are asked as one, which forces the respondent to choose one answer that may not apply to both questions. Negative wording can act to add confusion to a question as well. The more cognitively difficult a question is for people to answer, the more confusion there will be, which can reduce the construct validity of the item. Using double negatives can make questions more difficult for respondents to process. Consider the question, does it seem possible or does it seem impossible to you that the Nazi experimentation of the Jews never happened? In order to give your opinion about the Holocaust accurately, you must also be able to unpack the double negative of impossible and never. Negatively worded questions can reduce construct validity by adding to the cognitive load, which may interfere with getting people's true opinions. Question order may affect construct validity as well. Earlier terms can influence the way respondents interpret later items. Suppose the first item on a survey is rather sensitive. That might influence the way respondents answer subsequent questions because they were primed by the first item. One way to control for order effects is to make different versions of the survey with the questions in different orders. Researchers want accurate answers from their respondents. So what can they do to encourage this? Can respondents ever provide accurate responses on surveys? Self-reports are sometimes ideal for getting demographic information about age, gender, ethnicity, income, and so on. In other cases, self-report might be your only choice. For example, what were you thinking about when I called your name? While these self-report answers may not always be 100% accurate, they can still provide meaningful information to the researcher. Sometimes respondents use shortcuts when answering surveys, perhaps to finish them more quickly. These shortcuts often throw off the data and are inaccurate representations of responders' true thoughts. One such shortcut is a response set, also known as non-differentiation, which is a way of answering a number of questions in the same way. For example, selecting strongly agree for every answer. Response sets weaken construct validity because respondents aren't saying what they really think. Acquiescence, or yes-saying, is a type of response set in which people answer positively, yes, strongly agree, or agree, to a number of items instead of looking at each item individually. For example, a respondent might answer 5 to every item on a scale of subjective well-being, not because he is a happy person, but rather because he is using a yes-saying shortcut. People apparently have a bias to agree with or say yes to any item, no matter what it states, which was found in a research paper by Kronzik in 1999. Acquiescence can threaten construct validity because instead of measuring the construct of true feelings of well-being, the survey could simply be measuring the tendency to agree or the lack of motivation to think carefully. Another shortcut is to play it safe by choosing the response in the middle of the scale for all items. This is referred to as fence sitting. This might involve providing a neutral response or responding, "I don't know." Fence sitting weakens construct validity when respondents actually have a positive or negative opinion, but their responses indicate neutrality. It is difficult to distinguish fence sitters from those who truly feel neutral. One solution is to remove the neutral center option so that there are an even number of options, while another solution may be to simply use forced choice. Most of us like to look good in other people's eyes, so why shouldn't this extend to the way we respond on surveys? Socially desirable responding, or faking good, is when we try to look better than we are, smarter, stronger, thinner, happier, or more successful. Faking bad, on the other hand, is less common, but sometimes respondents try to look bad, more aggressive, more deviant, nastier, etc. One way to avoid this is to remind respondents that their responses are anonymous. However, sometimes this results in respondents not taking the survey seriously if they know their names won't be attached to it. You might include special items in the survey to identify socially desirable responders, or can ask people's friends to rate them. Researchers also can use computerized measures to evaluate implicit attitudes about sensitive topics. For example, the Implicit Association Test, or IAT. Sometimes people self-report more than they can know, So we should ask ourselves, are people capable of reporting accurately about their feelings, thoughts, and behaviors? For example, if I ask you why you always buy a particular brand of yogurt, you might not really know why, yet you tell me something that sounds reasonable. What about self-reporting memories of behaviors? For example, when was the last time you took your car to the car wash? What were you wearing on your 21st birthday? Where were you and what were you doing when you got the acceptance letter to Clemson? People's memories for events are not as accurate as they might like to believe. Additionally, confidence and accuracy are not related, so people might feel very confident about what they report, even if they're not accurate. A study in 2016 found little correspondence between 5-star ratings on Amazon and the ratings of the same products by Consumer Reports, which is an independent product rating firm. Researchers found that consumer ratings were instead correlated the most with cost of the product and the prestige of its brand. Studies like these suggest that people may not always be able to accurately report on the quality of products they buy. Another interesting point to consider when we ask ourselves how accurate our responses are. Another type of data that can be used to support a frequency claim is data from observational research, in which a researcher watches people or animals and systematically records their actions. Many researchers think that observing behavior is better than relying on self-report, given the issues we've discussed with the accuracy of self-reporting. As has already been mentioned, observational research can be the basis of frequency claims. For example, how often do people eat in fast food restaurants? Observational research can also be used for association claims and causal claims. Regardless of the kind of claim you're making, it's important that your observational measures be high in construct validity. One example of a frequency claim based on data from observational research is a study which observed how much people talk. Researcher Mathis Mel at the University of Arizona has developed an electronically activated recorder, or EAR, ear, to observe what people say in everyday conversations. The ear has a microphone and a digital recording device. Every 12.5 minutes, the ear records for 30 seconds. Then research assistants transcribe what the person said while being recorded. Mel and his colleagues found that despite stereotypes of women being more talkative than men, women did not use significantly more words than men as recorded by the ear. Here they were collecting their data by simply observing what people were naturally doing. Let's look at a couple other examples. In Canada, it wasn't unusual to hear in the popular media about parents acting aggressively at youth ice hockey games. Canadian researchers wanted to see how common this actually was, so they observed a sample of hockey games and recorded the frequency of both violent, negative behavior and positive, supporting behavior by parents. Researchers found that 64% of parents' comments were positive, and only 4% were negative, the rest being neutral. The results from this observational research did not support the reports in the media of parental violence. Another example was a study that wanted to observe families in the evening. In this research, both parents from dual-earner families were followed by a camera crew from the time they left work until 8 p.m. A variety of behaviors were coded from the videotapes, including the emotional tone of the parents and the topics of the conversations during dinner. Emotional tone, which rated each parent on a 7-point scale from 1 of cold or hostile to 7 of warm or happy. Emotional tone was slightly positive, of a 4.2 on average. In terms of the topics of dinner conversations, children were more likely to complain about the taste of the food, whereas parents were more likely to talk about how nutritious the food was. Again, these examples show how research can be performed by simply observing the natural behavior of people in their environments. Let's talk about the advantages of behavioral observations over self-report. What might have happened if the researchers had asked the participants to self-report? The college students certainly would not have been able to state how many words they spoke each day. The hockey parents might have reported that their own comments at the rink were mostly positive, but they might have exaggerated their reports of other parents' degree of negativity. And while parents could report on how they were feeling in the evening and at dinner, they might not have been able to describe how emotionally warm their expressions appeared to others, the part that mattered to the partner and the children. Observations can sometimes tell a more accurate story than self-reporting. We always need to be concerned with the construct validity of observations, and construct validity can be threatened by observer bias observer effects, and reactivity. Observer bias is when observers' expectations influence their interpretations of participants' behavior or the outcome of the research. Observers rate behaviors according to their own expectations or hypotheses, instead of rating behaviors objectively. Let's say that we all watched a videotape of a man in his mid-20s being interviewed. Before viewing the video, half of you were told that the man was a graduate student, and the other half were told that he was a criminal. Do you think this might influence your opinions of this man? Observer effects are when observers change the behavior of the participants to match the observer's expectations, also known as expectancy effects. Let's look at the bright and dull rats example. In this study, psychology undergraduates were given 5 rats and told to see how long it took for the rats to learn to run a maze. Each student was given a randomly selected group of rats. Half of the students were told that the rats were bred to be maze bright, and half were told that they were bred to be maze dull. The rats were actually all genetically similar, but the maze bright rats ran the maze faster each day with fewer mistakes, whereas the maze dull rats did not improve their performance over several days of testing. The study demonstrated that sometimes observers' expectations can actually influence the behavior of those they're observing. Have you ever heard of Clever Hans? Clever Hans was a horse who could add, subtract, multiply, and divide at least as well as a 5th grader. Hans was tutored in simple mathematics by his trainer and would tap his hoof to count. Additionally, the trainer was not the only person who could get Hans to do this type of math. Researchers suspected that Hans was picking up on subtle nonverbal cues from his questions. So they had one person whisper the first part of the problem in Hans's ear, and the second person whisper the second part of the math problem. Neither questioner knew the correct answer because they only knew the part of the problem they whispered, and in fact, Hans could not answer these math questions. Yes, Hans was clever, but not in math. He was skilled at detecting subtle nonverbal cues, such as changes in breath, changes in posture, and furrowed eyebrows. So again, these 2 examples demonstrate how the researchers' expectations can actually affect the behavior of participants, and thus the outcome of the study. So how do researchers prevent observer bias and observer effects? Researchers need well-trained observers. Having clear rating scales or codebooks is important as well. You can see an example of a good coding scheme here on the slide. In order to assess the construct validity of a coded measure, multiple observers can be used to determine the inter-rater reliability of the measures. If inter-rater reliability is low, then observers might need to be retrained, a clearer coding scheme for behaviors needs to be used, or possibly both. Remember that just because a measure is reliable doesn't mean it's valid. One way to specifically prevent observer bias and observer effects is to use a masked design, or a blind design. In a masked design, the observers do not know which conditions the participants have been assigned to, and they are not aware of what the study is actually about. This reduces the bias of the observer. Reactivity is when people change their behavior in some way when they know that someone else is watching them. For example, let's say you want to do some observational research in a preschool setting. If you simply walked in one day and sat down in the classroom to begin your observations, the children and teachers might change their behavior in a variety of ways. The children might be curious about what you're doing there and ask you a lot of questions. Some children might be afraid of you. The teachers might feel their teaching is being assessed. What should a good researcher do to prevent such reactivity? One solution is to blend in. Make yourself less obvious by sitting in the back of the classroom, or by being in an adjacent room behind a one-way mirror in a setting that's designated for such observations. The goal is to make unobtrusive observations to prevent reactivity. Solution 2 is to wait it out. Sometimes it's a good idea to have research participants get used to your presence by visiting a number of times so that they become more familiar with you being around. A third solution is to measure the behavior's results. Instead of actually measuring behaviors, sometimes researchers obtain unobtrusive data by measuring traces of behavior. For example, if you were interested in the amount and types of junk food that college students eat in the dorm, you could look at the wrappers in the dorm's garbage cans, rather than try to observe students actually eating the junk food. Lastly, it's important to think about how we can perform observational research in an ethical manner. Whether or not it's ethical for researchers to observe the behavior of others depends on the situation. Most researchers think it's ethical to observe people's behavior in public places, such as at concerts, on campus, or at the bus stop. It's also important that scientists don't specifically identify the people they observe when they report their research findings. On the other hand, the use of one-way mirrors or hidden cameras might be considered ethical in some situations, but in order to observe people's private behaviors, researchers need to get permission in advance. So the short answer of if it's ethical to observe people's behaviors is, well, it depends. So let's wrap up this week's topics. We talked about construct validity in both surveys and polls, as well as in behavioral observations. Surveys and polls need to consider the question's formats, that the questions are well worded, and that they are designed to encourage accurate responses. Observational research needs to be careful to watch out for other threats to its construct validity, such as observer bias, observer effects, and reactivity. Finally, it's important to ensure that the process of collecting information is done in an ethical manner. If you're observing someone either with or without their knowledge, it's important to consider if what you're doing is ethical.